Have you ever tried to measure something and gotten a different result each time? Maybe you've stepped on a scale in the morning and again at night, only to see the numbers that don't make sense. Or maybe you've used a ruler to measure the same object twice, but ended up with a slightly different number. If your measurements aren't consistent, how can you trust them? That's exactly why measurement system analysis, or MSA, is important. In Six Sigma, we make decisions based on data. But what if the data is wrong? If a company is measuring product weight, part size, or customer satisfaction, those numbers must be accurate and consistent. Otherwise, businesses make changes based on bad information, leading to wasted time, wasting money, and poor decisions. Think of it like baking a cake. If your measuring cups are off, your ingredients will be wrong, and the cake won't turn out right. The same thing happens in business. If measurements aren't reliable, the whole process can fall apart. That's why we use MSA to check whether our measurements are good enough to trust. There are two key ideas in MSA: precision and accuracy. Accuracy means how close a measurement is to the real value. If a scale says you weigh 150 pounds, but you really weigh 160, the scale's not accurate. Precision means getting the same result over and over again. If you step on the scale 5 times and it's always 150 pounds, it's precise, but still not accurate. The best measurement system is both precise and accurate. It gives results that are both correct and repeatable. If a business is measuring parts for an airplane, precision and accuracy are the difference between a safe flight and a dangerous one. Sometimes measurement errors aren't obvious. Even if a system seems accurate, it can have hidden problems like bias, linearity, and stability. Bias is a consistent error in one direction. If a thermometer always reads 2 degrees too high, it's biased. Linearity checks if a measurement system is accurate equally across its full range. A scale might be correct on low weights, but wrong on higher weights. And stability means the measurement system stays consistent over time. If a machine gives different readings in the morning than at night, it's unstable. By testing for bias, linearity, and stability, we can make sure measurement tools stay trustworthy and reliable. Even the best measurement tools can have variation. Gauge repeatedly Gauge repeatability and reproducibility, Gage R&R, helps us figure out if measurement errors come from the tool itself or the people using it. Repeatability checks if the same person using the same tool gets the same result every time. If a worker measures a part multiple times and gets different numbers, there's a repeatability problem. Reproducibility checks if different people use the same tool get the same result. If one worker measures 5 inches and another measures 4.8 inches, the tool might be fine, but the method might be inconsistent. If a company has poor gauge R&R, it means the measurement system isn't reliable. That might mean rejecting good products or approving defective ones. That's why every business needs to check for measurement consistency before making decisions. Not all measurements are the same. Some are variable, meaning they use numbers like weight or temperature. Others are attribute-based, meaning they use categories like pass, fail, or yes, no. Variable MSA deals with numerical data, such as measuring the exact size of a part. An attribute MSA deals with non-numerical decisions, like whether a product meets quality standards. Both types of measurement systems must be tested for reliability. A manufacturing plant might need variable MSA to check part dimensions, while a customer service team might use attribute MSA to check if complaints were handled correctly. Once we have reliable measurements, the next step is to see if a process is actually capable of producing good results. That's where process capability analysis comes in. A process is capable if it consistently produces outputs that meet customer expectations. If a company makes phone cases that should be exactly 5 inches wide, they need to check whether their machines are consistently producing cases within this acceptable size range. To check process capability, we look at two key ideas: stability and capability. Stability is checking to see, is the process consistent over time? If one batch of phone cases is perfect, but the next batch is too small, we consider the process to be unstable. And capability, does the process produce results which are within the allowed limits? If a process is always too close to the upper limit or lower limit, even small changes could lead to defects. A stable, capable process produces high-quality results with little waste. A process that isn't capable might require constant rework, leading to delays, extra cost, and unhappy customers. Even after a process is running well, businesses need a way to monitor performance. If things start drifting off course, small issues can turn into big problems. There are different ways to track process capability. We could use the capability index. These numbers show how well a process meets specifications. If CP is too low, the process might not be producing quality products consistently. We could use control charts. These help track performance over time, and if a process suddenly starts making more mistakes, a control chart can spot the problem for us before it gets worse. And we can look at defect rates. Tracking defects per million opportunities, DPMO, helps us identify whether quality is improving or getting worse. By keeping an eye on process capability, businesses can catch problems early, reduce waste, and maintain quality. Measurement system analysis and process capability might sound too technical, but they affect everyday life. Imagine if your car's speedometer was off by 10 miles per hour. You could get a speeding ticket without even realizing it. Or if your doctor's thermometer was always 2 degrees too low, they might think you didn't have a fever when you actually do. The same risks apply in business. If a company relies on bad measurements, they might make bad decisions, wasting time, money, and resources. But when they trust their data, they can improve quality, reduce cost, and make customers happy. The next time you measure something, think about this. Is my measurement tool accurate and precise? Are my measurements consistent every time? And can I trust the data I'm using? Because in Six Sigma, better measurements lead to better decisions, and better decisions lead to better results.